In this video, we're going to look at topic 6, example 4, solve problems involving compound inequalities. Enrique plans a diet for his dog River. River consumes between 510 and 540 calories per day. Each serving of dog food has 320 calories, and each dog treat has 15 calories. Okay, so let's note that. So a serving of dog food has 320 calories, and each dog treat has 15 calories. We also need to note that consumes between 510 and 540. Between is important. If River eats 1.5 servings of dog food each day, how many treats can she have? So that 1.5 servings of dog food goes with the 320 calories. All right, so what we want to do is we want to set up a compound inequality because we have a minimum and maximum. We have a minimum of 510 calories that River is allowed to consume and up to 540 calories. So they want to stay in there basically to maintain their weight. Anything under 510, they're probably going to lose too much weight and not get the nutrition that they need. And anything over 540, they'll wind up gaining weight and could have some health problems. So we're looking for, we have 1.5 servings of food each day. So if each serving of food is 320 calories, we're having 1.5 of those per day. So 320 times 1.5 would be 480. So we know 480 calories from the food. And then in terms of dog treats, we know that there's 15 calories. So I'm going to keep highlighting these. In terms of the dog food, we know that there's 15 calories per treat. So we can show that as, we'll call the treat X. We can say 15X. All right, because we don't know how many treats. That's what we're trying to figure out. How many treats can she have per day? So that would be here and there. Oops. Let's fix that. All right. So now that we have that information, we can set up a set up an inequality. So we know that River consumes between 510, so that is our lowest amount. So 510, which is going to be the minimum. So this is going to be an end statement, right? Because we're looking for between these two numbers, not or. It's not one or the other. It has to be between them. So 510 is less than or equal to, well, to determine the total number of calories, we know that River is going to eat a guaranteed 480 calories from food, and then on top of that would be 15x, right? Depending on how many treats that River has, will determine the additional calories that she consumes through treats. And then we want to know at most there's going to be 540 calories. So the max would be 540. All right, so the 480 is the calories from food. The 15x is the calories from treats, and the 510 and the 540 are our minimum and maximum calories, allowed amount. All right, so now that we have that, we can solve this. And I'm going to solve it as a compound inequality, keeping it together. So I'm going to subtract 480 from the left, middle, and right sides. So 510 minus 480 would be 30, which is less than or equal to 15x, which is less than or equal to 540 minus 480 is 60. Now, I didn't mention this, but we put the inequality sign with the equal sign because it does seem like she's allowed to have 510 and 540 calories. All right, it has to be between that. If you didn't put the inequality sign, it's not very clear in this example whether those numbers are inclusive. So if you did leave out the inequality sign, it really, it's debatable in this case. It's not very clear whether they can have those amounts. Anyway, I would then divide by 15. So I'd have 2 is less than or equal to x, which is less than or equal to 4. All right. So the solution to your inequality is this piece right here. This 2 is less than x is less than 4. X, remember, being the treats. So what this tells me is that River can have between 2 and 4 treats per day. So that's the answer to the question. Always make sure you actually answer the question. It does say how many treats can she have. Just solving the inequality, this right here, that is the solution to the inequality, but it doesn't answer the question. We want to put it in context. So make sure you do that. All right. Setting up an inequality usually is not too bad. You normally just have to decide whether it is going to be an and or an or statement. In this case, it was an and statement because we have a minimum and maximum, and we're trying to stay between those two numbers, not on the outsides of those numbers. So there you go, and that is all.